For centuries, humans have looked out at the natural world and wondered, do animals speak? This question has fascinated philosophers, scientists, and curious minds alike. From the ancient Greeks who believed in the divine language of birds to modern researchers who use cutting-edge technology to decode animal sounds, the quest to understand animal communication has been a long and intriguing journey. Do they have their own languages, their own ways of sharing information and expressing themselves? The idea that animals might have complex systems of communication is both thrilling and humbling. It suggests that we are not alone in our ability to convey thoughts, emotions, and intentions. We've watched bees dance, birds sing, and dolphins click and whistle. Each of these behaviors is a form of communication, a way for these creatures to share information with one another. Bees, for example, perform intricate dances to inform their hive mates about the location of food sources. Birds use songs to attract mates and defend their territories. Dolphins employ a variety of sounds to coordinate hunting and maintain social bonds. We felt the nuzzle of a dog and the purr of a cat. These simple gestures are laden with meaning. A dog's nuzzle can be a sign of affection, a request for attention, or even a way to comfort us when we're feeling down. A cat's purr, often associated with contentment, can also indicate a range of emotions from happiness to anxiety. We've sensed a form of communication, a language beyond our immediate grasp. This unspoken language is rich and varied, encompassing not just sounds and gestures, but also scents, body postures, and even electrical signals. Each species has its own unique way of conveying information, shaped by millions of years of evolution. Today, we stand on the cusp of a revolution in understanding animal communication. Advances in technology, particularly in the fields of bioacoustics and artificial intelligence, are opening up new possibilities for decoding the languages of other species. Researchers are now able to record and analyze animal sounds with unprecedented precision, revealing patterns and structures that were previously hidden. Artificial intelligence, with its ability to analyze vast amounts of data and identify complex patterns, offers a powerful tool for decoding the languages of other species. Machine learning algorithms can sift through hours of recordings, identifying subtle variations in pitch, rhythm, and frequency that might be missed by the human ear. This technology is helping us to unlock the secrets of animal communication, one sound at a time. Imagine a world where we could understand the wag of a dog's tail, not just as a sign of happiness, but as a specific message. Perhaps a wag to the left means, "I'm excited to see you," while a wag to the right means, "I'm feeling playful." The possibilities are endless and fascinating. Imagine deciphering the songs of whales, the dances of bees, and the silent communication of fish. Each of these forms of communication is a window into the minds of these creatures, offering us a glimpse of their inner lives. Whales, for example, are known to produce complex songs that can travel for miles underwater. These songs are thought to play a role in mating and social bonding. Bees use their dances to convey detailed information about the location and quality of food sources. Fish, on the other hand, often rely on visual signals and body movements to communicate with one another. This is the promise of AI and the future of our relationship with the natural world. By bridging the communication gap between humans and animals, we can foster a deeper understanding and appreciation of the diverse forms of life that share our planet. This technology has the potential to transform not only our scientific knowledge, but also our ethical and emotional connections to other species. This journey of discovery is not just about satisfying our curiosity, it's about building a more compassionate and informed world. By understanding the languages of animals, we can better protect their habitats, ensure their welfare, and learn from their intelligence and adaptability. Understanding animal communication has profound implications for conservation, animal welfare, and our understanding of intelligence itself. It challenges us to rethink our assumptions about the uniqueness of human language and cognition. It also highlights the importance of preserving the natural environments that are essential for the survival of these communication systems. It challenges us to reconsider our place in the web of life and to recognize the rich tapestry of communication that exists all around us. As we continue to explore and decode the languages of nature, we are reminded of the interconnectedness of all living beings and the beauty of the world we share. When we think of language, we often think of human speech words, sentences, grammar. Our minds immediately conjure up images of conversations, debates, and storytelling. But language, in its broadest sense, is not confined to humans alone. But communication in the animal kingdom is incredibly diverse, encompassing a vast repertoire of signals and sensory experiences far beyond our limited human perception. From the depths of the oceans to the highest treetops, animals have developed intricate ways to convey messages essential for their survival and social interactions. Animals communicate through sound, of course. The auditory signals they produce can be as varied as the species themselves. Bird songs, wolf howls, and frog croaks all carry information about territory, mating, and danger. Each sound is a carefully crafted message, honed by evolution to ensure it reaches the intended recipient. But communication extends far beyond what our ears can detect. The animal kingdom is rich with non-auditory signals that are just as vital. Visual cues are equally important. These visual signals can be immediate and striking, often conveying complex messages in an instant. Think of the vibrant colors of a peacock's tail, the threatening posture of a cobra, or the playful bow of a dog. Each of these visual displays is a form of communication, designed to attract, warn, or invite interaction. These visual signals convey instant and often complex messages. They can indicate readiness to mate, signal a threat, or invite play. The world of animal communication also extends to the realms of smell and touch. These senses are often overlooked by humans but are crucial for many species. Pheromones, chemical signals released by animals, play a crucial role in attracting mates, marking territory, and even signaling danger. These invisible messages can travel long distances and linger in the environment, providing a lasting form of communication. And who hasn't felt the deep connection of a gentle touch, a hug, or a groom between animals? These tactile interactions are fundamental in building and maintaining social bonds. These physical interactions strengthen bonds and communicate affection and reassurance. They are a testament to the emotional depth and social complexity found in the animal kingdom, reminding us that communication is not just about words, but about connection. The sheer complexity and diversity of animal communication have long posed a challenge to scientists. From the intricate dances of bees to the elaborate songs of whales, the ways in which animals convey information are as varied as they are fascinating. Each species has developed its own unique methods of communication, tailored to its environment and social structure. This diversity, while captivating, also makes it incredibly difficult to decode the languages of the animal kingdom. Traditional methods of observation and analysis, while valuable, can only take us so far. Scientists have spent countless hours in the field, meticulously recording animal behaviors and vocalizations. These efforts have yielded significant insights, but they are often limited by the sheer volume of data and the subjective nature of human observation. Manual data analysis is time-consuming and can miss subtle patterns that are crucial for understanding complex communication systems. This is where artificial intelligence emerges as a potential game-changer. AI technology has the capability to process and analyze vast amounts of data far more quickly and accurately than a human ever could. By leveraging machine learning algorithms, scientists can uncover patterns and correlations that were previously hidden. This opens up new possibilities for understanding the nuances of animal communication. AI excels at recognizing patterns in vast datasets, patterns that might be too subtle or complex for humans to detect. For instance, it can analyze the frequency, duration, and modulation of animal calls, identifying distinct vocal signatures and variations. This level of detail is essential for decoding the meanings behind different sounds and behaviors. By feeding AI systems with recordings of animal vocalizations, videos of their behavior, and even data on their chemical signals, we can begin to decipher the hidden structures and meanings within these communication systems. This multimodal approach allows for a more comprehensive understanding of how animals interact with each other and their environment. The integration of various data types enhances the accuracy and depth of the analysis. Imagine an AI system that can analyze thousands of hours of birdsong recordings. Such a system could not only identify individual birds, but also track their interactions over time. It could discern patterns in their songs that indicate mating calls, territorial disputes, or even warnings of predators. The ability to process such large data sets allows for a level of insight that was previously unattainable. The AI can identify individual birds, recognize variations in calls depending on the context, and even predict the likelihood of a territorial dispute based on the acoustic signals exchanged. This predictive capability is particularly exciting as it could lead to new discoveries about animal behavior and social structures. Understanding these dynamics is crucial for conservation efforts and for fostering a deeper appreciation of the natural world. Such a system would provide unprecedented insights into the social lives and communication networks of these feathered creatures. By mapping out these networks, scientists can gain a better understanding of how information flows within animal communities. This knowledge could inform strategies for protecting endangered species and preserving biodiversity. The potential applications of AI in this field are vast, promising a future where we can truly begin to understand the languages of the animal kingdom. Section 4. Deciphering the Canine Lexicon. AI listens to dog barks. Dogs, our domesticated companions, offer a fascinating window into the potential of AI for understanding animal communication. While we've developed a basic understanding of dog body language, their barks, often dismissed as simple noise, hold a surprising depth of information. In recent years, researchers have begun using AI to analyze dog barks. By training algorithms on thousands of recordings paired with information about the dog's behavior and environment, AI systems are learning to identify subtle variations in barks that correspond to different emotions and intentions. Want to know if your dog is truly happy or just putting on a brave face? AI might soon be able to tell you. Section 5. Whale songs across the ocean. AI connects the calls. Whales, the majestic giants of the ocean, communicate using complex and haunting songs that can travel for hundreds of miles underwater. These songs, essential for social bonding, mating, and navigation, have captivated scientists and the public alike. AI is proving to be an invaluable tool for deciphering the intricacies of whale song. By analyzing recordings from different whale populations around the world, AI can identify distinct dialects, track the movement of individuals and groups, and even shed light on the cultural transmission of whale songs across generations. This knowledge is critical for protecting these vulnerable creatures and their ocean habitats.